Today I'd like to talk to you about normal distribution. And in order to talk about normal distribution, I want to just review some things from your past about statistics that you should know. So I have this example. The number of games won by the teams in the Eastern Conference for 1997 to 1998 regular season of the National Hockey League are shown as follows. So once we're given a set of data, we can find certain measures of central tendency on that data. When they're called measures of central tendency, it's because we're finding the centers of the data. One such center is called the mean. When you find the mean, you average the numbers. It means you would add them all up and divide by how many they are. Means are always denoted as X bar. And yes, that is an X with a bar over the top. That means the mean. A second center is called a median. A median means you put the terms in order from lowest to highest, and then you count off to find which one is smack dab in the middle. And the last tendency we have is called a mode. Why it is a central tendency is because it is the term that occurs the most frequently. So in this data, we would have 36, 29, 40, 34, 48, 33, 25, 30, 37, 17, 42, 24, 62. We would have no mode because I do not see any numbers repeating themselves. However, if I had two 24s, 24 would be the mode. Then we have things called measures of dispersion. To disperse data is how it falls out, how it is spread out. So dispersion is the spread. One measure of spread is called the range. This is different than the range of our functions. That was our y values. The statistical range means to take the difference from the largest term minus the smallest term. So you are seeing how many units of data are between your biggest and your smallest. A second measure of dispersion is called standard deviation. That is the typical difference between the mean and a term. Standard deviation is noted as sigma, and this is lowercase sigma. And it is computed by doing the square root of the difference of your first term minus your mean squared, plus your second term minus your mean squared, plus your third term minus your mean squared, etc., divided by how many you had. Then we have a measure of dispersion called variance. Variance simply means to take your standard deviation and square it. So these were things you should have learned in the past. And we are going to use a normal distribution. We are going to use means and standard deviations. So that is why I wanted to refresh what those were. Now, something else that shows our dispersion is we call it skewness. It's how our data falls. So when we have a true bell-shaped curve, this is called a normal distribution. Because I have right in the middle is my mean. And I have 50% of my data to the left equally and 50% of my data to the right equally. When I am completely symmetric, it is called a bell-shaped curve. My mean is the same as my mode, which is the same as my median. All of those centers are right at the center. I can have data that is called left skewed, which would mean there would be data the tail would come to the left of the data, or I could have data that is right skewed, which means the tail would come to the right of the data. By the tail, I mean this part down here. So when you have a left skewed data, that means your mean is closer to the left end of the data. When you have right skewed data, that means your mean is closest to the right side of the data. But as I said, today we're going to talk about normal distribution, so we should end up with this true bell-shaped symmetrical curve. So normal distributions, again, have a bell-shaped curve, and the areas under the curve are consistent. They are equal. So when you do a normal distribution, it usually follows what we call an empirical rule. Right in the middle is your mean. That's my X bar. Then from the middle, I go right 1 deviation, so that would be plus 1 deviation, plus 2 deviations, plus 3 deviations, all the way out to the tail would be at most plus 4 deviations. If I go to the left, that would be negative 1 deviation, negative 2 deviations, negative 3 deviations, and out to the end, negative 4 deviations. So if it is going to be symmetric, from the mean to 1 deviation is 34% of the data. So that would be 34% to the left as well. So between 1 deviation from the mean, that gives us 68% of the area. If I go between 1 and 2 deviations, that is 13.5% of the data, whether it is to the right between 1 and 2 or to the left between 1 and 2. So if I would add up all the data between 2 deviations, it would be 13.5, 34, 34, and 13.5. That would give me 95% of the area lies within those 2 deviations of the mean. And then the last one I have is between 2 and 3 deviations is 2.35% of the data, whether it is to the left or to the right. So if I add up between 3 deviations off of the mean, I get 99.7% of the data is within 3 deviations of the mean. So all that leaves me with is that 0.3%. So if I divide that equally, at the tail ends I get 0.15%, 0.15%. So when you do a bell-shaped curve, they should pretty close follow this empirical rule. So what are you going to have to know? You are going to have to know these 4 percentages. Between the mean and 1 deviation is 34%, whether I'm at the right or the left. Between 1 and 2 is 13.5%. Between 2 and 3 is 2.35%. And between 3 and 4 is 0.15%. You must include the percentage sign. Otherwise, you have a different number. So you will be given pictures like this. What percent of area is under the curve? So right here is my X bar. So this is negative 1 deviation, negative 2 deviations. So between 1 and 2 deviations is 13.5% of the data is shaded. So again, smack dab in the middle is my X bar to 1 deviation, to 2 deviations, and then I go left 1 deviation. So this is 34, this is 34%, and this is 13.5%. So 34% plus 34% plus 13.5% gives me 81.5% of the data is shaded under the curve. Then you will be asked questions like this. The price of sandals is normally distributed with a mean of $36 and a standard deviation of $9. So if I'm going to start my bell-shaped curve, here is my mean, that is $36. So when I go plus 1 deviation to the right, I'm going to add $9 onto there. So that would give me $45. 2 deviations to the right will be 54. So I add 2 nines. 3 deviations to the right will be 63. And then out here on the tail, another deviation would be 72. So 1 deviation to the left, 2 deviations to the left, 3 deviations to the left, and finally the 4th would bring me 36 minus $9 would give me 27 at 1 deviation to the left. 36 minus 2 nines would give me 18. 36 minus 3 nines would give me 9. And 36 minus 4 nines would give me 0. So this is how the price of my sandals falls out, between $0 to $72. Now, let's read the question. What percent is between 18 and 72? Well, here's 18 to 72 is all of this. So, from this point out, I have 50% of my data. So for A, I'm starting with 50% of my data. And then between the mean and 1 deviation is 34%. And between 1 and 2 deviations is 13.5%. So when I add all that up, I get 97.5% of the data. Now part B says, what is the probability? So then I'm just going to give a decimal answer. That a randomly chosen pair is between $9 and $18. So 9 and 18 falls right here. So when I do part B, this is 1, 2, 3. Between 2 and 3 deviations is 2.35%. Okay, let's try another one. This time, the weight of strawberries is packed in a medium-sized container is normally distributed. That means our bell-shaped curve. A mean of 16.18 ounces and a standard deviation of 0.34 ounces. This time it says if you randomly choose 2 containers, what's the probability both will lie less than 15.5? So let's first get our numbers on here. My mean was at 16.18. So add 0.34 to get to my first, second, third, and fourth deviation. That gives me 16.52, 16.86, 17.2, up to 17.54. Then to the left, -1, -2, -3, and out here, -4. So I'm going to subtract 2.34. And I get 15.84, 15.5, 15.16, and 14.82. So it was asking me less than 15.5. So that would be out here. So this is 2.35% and 0.15%. If I add that together, I get 2.5%. So I'm going to change that percent to a decimal. So I move this 2 places. So that is 0.025 for 1 container. So this is 1 container. And in probability means to multiply. So I have and 2 containers. So 0.025 times 0.025 gives me 0.0000625. So this is my probability that the 2 containers I choose are less than 15.5 ounces. Okay, let's try another one. The number of people seeing a movie on a weekend is normally distributed. Excuse me, that's on a weeknight. The mean is 224 and the standard deviation is 17. What's the probability that between 241 and 275 people attend? So I need my bell-shaped curve. My mean was at 224, so I need 1, 2, 3, 4. 1, 2, 3, 4. So when I add 17, I get 241, 258, 275, and 292. Then when I subtract 17, I get 207, 190, 173, and 156. So this time I am going between 241 and 275. So that is 13.5% plus 2.35%, which gives me 15.85% of the people will attend movies on the weeknight. If I chose 4 weeknights where the attendance was below 207 for all 4 nights, here's 207 and below. So that is 0.16 times 0.16 for the second night, 0.16 for the third night, 0.16 for the fourth night, because it is 13.5%, 2.35%, and 0.15%. That adds up to 16%. So to probability, move my decimal 2 places. And this gives me 0.0655%. Or decimal probability 0.00655. And I guess it did ask for the probability. You should now be able to do your normal distributions.